With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The question is, the first order reaction has a rate constant 1.5 into 10 power minus 6 per second at 200 degrees Celsius. If the reaction is allowed to run for 10 hours at the same temperature, what percentage of initial concentration would have changed into the product? You also have to determine the half-life period of the reaction, right? So the first thing that you determine is the percentage of the initial concentration, right? That would have changed to the product. And the next thing is that we have to find out the half-life period of this reaction. Okay. Now, as it is given that it is a first order reaction, the rate constant is given to you as 1.5 into 10 to the power minus 6 second inverse. From here, you can find out the half-life for the reaction. As it is a first order reaction, the half-life is 0.693 divided by K. So this will become 0.693 divided by 1.5 into 10 to the power minus 6 seconds, right? And this will come out to be equal to 462,000 for 128.33 hours. This is what you will get as the half-life. Now you have to determine the percentage of the initial concentration changed to the product as well. Now for a first order reaction, so let us first assume that you have to assume that let the initial concentration, right, let the initial concentration A be 100, right? We are assuming it to be 100. Now it is given to you that the reaction runs for 10 hours, right? So the time is equal to 10 hour, okay? And 10 hour means 10 into, you have to convert it into maybe seconds, right? You can convert it into seconds. So if you have to convert 10 hours into seconds, then 1 hour has 60 minutes and each minute has 60 seconds, right? So this is going to give you in seconds. So this will be equal to 36,000 seconds, right? So you basically have to find out the value of x, right? So if initial amount is 100 and x is the amount reacted, right? X is the amount reacted. That is what you have to determine, okay? Now for a first order reaction, you have k is equal to 2.303 by t log of initial concentration, which is 100, and the concentration at time t, which is 100 minus x, right? X is the amount reacted. So what is the amount left? 100 minus x. So x is what you have to determine in percentage. Now the value of k you have, the value of t you have, right? You have to just find out the value of x from here, okay? The value of k given to you is 1.5 into 10 to the power minus 6, which is equal to 2.303. What is the time? 36,000, which will be 3.6 into 10 to the power 4 seconds, right? Log of 100 divided by 100 minus x. Now, when we will solve this, what we are going to get? When we will calculate this, the value of x will come out to be equal to 5.2, right? The value of x will come out to be 5.2. So actually this is the percentage only because we assumed the initial concentration to be 100. So we are assuming 100% of the initial concentration, right? So 100 is the initial concentration. So out of 100, if initially it was 100% of the reactant, then after some time t, 5.2% of it was reacted, right? So therefore, if we talk about the percentage change, that is 5.2% only. So we assumed A to be 100 deliberately so that whatever our answer comes in percentage only. So 5.2% is the correct answer for the question.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.